Hi everyone, Dave here. I'm currently in the process of upgrading my solar workshop with a new inverter and off-grid power system. In this episode, I'm trying a new method to connect larger cables to a Make Sky Blue charge controller, plus mounting it on a power board with a new inverter. The solar workshop is also getting some new lithium iron phosphate batteries. The goal is to provide off electrical grid power for air conditioning, a video processing computer, shop tools, and appliances. I hope you enjoyed this episode. Thanks for watching. Hi folks, Dave here. Well, I got a new camera. It's a old used GoPro, and I got a head mount for it. So I hope some headcam footage will make the channel better. We'll see how that goes. I've never done this before, but I've wanted to. So I'm going to put this camera on and let's try it out. So here's the test view for the headcam. It's supposed to be stabilized, and I hope that I'll be able to walk around in my workshop and use both hands at the same time. Hands-free really speeds things up. And then I should be able to go over my workbench and transition to the workbench without too much effort. Or at least that's what I hope. Alright, so the plan today is to get a charge controller on this wall here. This is the one I've had for quite a while. This is an auxiliary power backup system. Now I have a little bit of space left here on this board, and I've maintained that for actually a couple of years, something like that. I reserved this space because I knew I'd want to expand. This is my original board right here, and this is kind of like been here a long time. The next charge controller will go somewhere in this area, and then I have this inverter that I just got, and I've been testing this and I like it. It's very, very heavy. It's a low frequency inverter, but that's going to go probably in this area here. First job though is actually to get the charge controller working. And this charge controller is a Make Sky Blue 60 amp. I really like these because they're simple, they don't cost a huge amount of money, and they work. They're a no-frills charge controller, robust construction, nice metal case, not much plastic. Alright, so the Make Sky Blue 60 amp charge controller does have a slight challenge in its deployment, and that is these bus bars, or these terminals here, are very difficult to get large wires into. Actually, you can't. You just can't. It is what it is. I have developed a workaround that I'm going to try. I'm not saying it's going to work, but I'm going to give it a shot and we'll see what happens. I'm going to use this stuff here. This may look like solder, but it's not. It's actually tin copper wire. It's also called bus wire. It's fairly thick. What I'm going to do is I'm going to cut some of that off. Let's see if I can find my cutters and a pair of pliers. And what I want to do is make a piece that's going to go right in here in these terminals here. If you look closely at the Make Sky Blue controller, all of the terminals are doubled up because they are small gauge. So I'm going to make a part that's going to go right in there and connect the main cable. Or at least I'm going to try that. And if it doesn't work, well, maybe by then I'll have another solution. So I'm going to make a little loop like this. Let's see what that does. Might be a little too short. I may have to try this several times before I get it right. And next thing is I need to get some hardware. Let's go with the M5 because I have just bought a lot of those. I have some of these I got from a monitor arm for a computer, and I have these that are M5. And what I'd like to do, of course I got to make sure I put them in the right location. I would like to put a bolt, and this is a serrated nut. Put that right through there. And the actual amount of wire that's going to carry the 30 or 40 amps from the charge controller isn't very much. I suspect that this particular loop that I've made is going to be too short, so let me see what I can do to correct that. Okay, I had a go at it, and I made a couple more. Let's try this one for battery positive. And we're going to take the positive and just feed that right through. Let's try it anyway. If this doesn't work, perhaps by then I'll have another solution, but right now this will get me up and running. I don't have to cut any of my cables, and we'll see what happens. So that'll just go right in there like that. If I get this just right, it should be able to make good contact with the terminals. A little bit tricky to get these right though. We'll see. I've Gonna have to put some heat shrink on these, of course. Where's my screwdriver? Can never find the screwdriver when I need it. Okay, let's loosen these up. Well, this will at least make the charge controller turn on. I don't say it's going to be able to handle all the power, but it's worth a try. And you can see I have some decent separation between the positive and negative. I can now adjust this side, bring it a little closer to reduce the connection resistance. And then I'll need some heat shrink, so let me get some of that. Let's try black color for this side. And I'm not going to heat shrink it just yet until I'm sure how this is going to work, and I'm going to use double layered everything, possibly triple layer, to prevent short circuits and accidental mishaps. Let's get a positive. Actually, I don't think this is going to be big enough, so yeah, I don't think it's big enough. Nope, it's not going to be. I'll be forced to use black on both sides most likely. Alright, I went ahead and found another piece of heat shrink. It's mismatched for now. I will need to order some heat shrink that's big enough. This will temporarily protect the connections while I'm testing this out. It'll do for now. It's not great looking, but now we have some decent sized cables for this charge controller just to get it running. I probably will upgrade these later. Currently, power storage is very limited in the workshop. That means I can't run my computer or my air conditioner for very long at all. And in order to do that every day, I need a good charge controller that can push out 40 amps continuous. I'm also going to be doing a modification to this charge controller, and I'll show that as soon as possible. I may do that now or wait a couple of days. So what am I going to be doing with these batteries? Well, these are going to be powering my off-grid air conditioning for my solar workshop. I'll insert some clips of that here. It's basically a metal building, and it has a 5000 BTU air conditioner. These batteries are going to provide off-grid power 24 hours around the clock, and they are big enough to do the job, I'm quite sure of that. To charge these WattCycle batteries, I'm going to be using this Make Sky Blue MPPT solar charge controller. This is a 60 amp model. I've got some cables test fit to it, although I may upgrade them later. Over here I have some other parts, some additional cables I've acquired for the project, and I've got some other hardware. I've got a circuit breaker, some bus bars, bolts and nuts, and I've also got some fuses. First step is to get an idea where I want to start putting the batteries, and for starters I think I'm just going to line them up like this, and the inverter will probably sit starting right about here, and then I'll have to put all my cables and stuff, and that's going to take a while, and I'll go ahead and record some of that work as it continues forward. Okay, unfortunately, I don't have the correct cables to parallel these, so I will use some temporary longer cables instead. These are just a little bit too short, and I will order some that are probably 8 inches. These are 6 inches, and for now I have cables that are longer, and they will do the job until I can replace them. Well, it's early morning, and thank God the neighbors are quiet for the moment. And a few other things got out of my way, so I can do some work in here in the solar workshop. Here are the batteries that I'm going to be installing. These are the first batteries, 100 amp hour, WattCycle 12 volts. I just got done testing those the other day. And right here we're going to have all of the equipment installed. I have already marked and measured my layout on this board. I figured you guys didn't want to see me drilling holes and drawing lines on a board, so I have already marked and measured the layout and all that, and I'm ready to mount the inverter and the charge controller on the board. There's going to be room for expansion. I have carefully planned this so that I can expand the system later. There will be 3 charge controllers. They'll probably all be Make Sky Blue charge controllers. These are nice simple units. They do the job, and I've been quite impressed with them so far. In fact, I've had that one for, well, probably a couple of years, and I have another one that's even older than that. I've really been liking this softbox. It's called a softbox. It is AC powered, unfortunately. And you can see I have that plugged into the solar generator over here on the workbench, which is starting to run out of power, down to 20%, but I'm not too worried about it. It doesn't take a lot of power. And it allows me to see what I'm doing, which is kind of useful. Well, I'm going to strap on the GoPro here. It's not comfortable to wear. And this thing, I tell you what, it locks up, it crashes, loses footage, but it does get some good footage when it works. So I'm going to try to incorporate this camera into my routine as much as I can. Okay, it's time to get the inverter and the charge controller installed. I also have some other accessories that I will be showing throughout this video, including a circuit breaker and some cables and things like that. Alright, let's get to it. Okay, here's the inverter. I have to get this on there first because this thing is very heavy. I'm sure you know this type of inverter weighs quite a bit. Anyway, I need to get this over to the board. I've got a little setup I'm going to do to hold it in place while I mount it. Let's go ahead and get that. So I'm going to use a towel and some blocks of wood right here. I'm going to make a little platform here to put the inverter on and hold the weight while I'm working on it. And it's a little bit precarious, but I don't have any help, so it is what it is. It's going to have to be that way. Let's get the inverter. Yeah. Let's see if I can line up the holes that I marked and drilled earlier. Oh, actually, I'm pretty close. Yeah, it's pretty close, actually. Not bad. Yeah. Okay, so I got one of the holes lined up already. I'm using these deck screws here. I'm not taking any chances. That's on the left side. And I'm going to use standard stainless steel screws on the right side. Eventually I will add more screws. This is just to get the inverter in place, which is quite a task. And okay, looks like I need to put my extension bit on. This is pretty precarious holding this inverter in place, so I do everything one-handed. Yep. Alright, let's see if I can get the screw in there. Okay, I got one screw in there. Next job is to try to hold on to that inverter and get a screw in on the left, which is going to be over here. If I can line it up. It's a little bit off there. Hopefully I can get this big deck screw attached because this is really strong. Then I can rest a little bit. Alright, that's a little less dangerous. However, it's not enough. Now I got to put another screw in. And that would be on the left again. I'm hoping they will line up. They should line up. And yeah, I actually got them in the wrong holes on the inverter, so I'll have to fix this mistake and I'll be right back. Alright, I had to redo the mounting of the inverter at the top. I messed up on which part of the bracket I was mounting the screws in. I had to take it off the wall and then put these two screws in there again. I left that part out. I don't think anybody wants to watch that. And now what I'm doing is installing the rest of the screws. And that will be a process. I'm going to go ahead and get the other deck screw in, this one here. And it's making me nervous having only two screws. 3 would be better. And that isn't going anywhere. There we go. And I'm going to put the 4th screw in, and then I can somewhat rest, I guess. The chances of that coming off the wall with 4 screws is pretty low. There's only plywood on the right hand side. There's no 2x4 material. If you want to see me build this board, the rest of it, the wood part, the woodworking, the construction, and all of the other things that are on here, I have a series called Solar Power Equipment Board. It's a much older video series, and I will put that in the description. I'll put a link to it in the description. Alright, the inverter is there. I believe it is somewhat straight. I may fine-tune it later. Everything needs to be straight. Believe me, I take great pains to make sure everything is straight. Let's tighten the screw up here. now for the charge controller, which I hope will be a lot easier than that thing was. Don't feel like doing that again for a while. I've already put the mounting brackets on the charge controller. Let's see if I can do this. Actually, let's take that bit extension off. I don't think that's helping my case any. Let's try it again. There we go, got one screw in. I'm using 3/4 inch stainless steel sheet metal screws to do this. I use them all the time in plywood. It works just fine. Try to get the bottom ones in without dropping them behind this board, which is often what happens. Alright, one to go. I will line the charge controller up later. You can see that I have survey marks on the board to keep everything straight and in alignment. Actually, let's go ahead and try to line this up. What I'm doing is I'm just sighting down the line here. I like to keep everything straight on the board. And once the charge controller is straight, I can tighten the screws. We will see. Yeah, that looks pretty good. In the future, there's going to be a third charge controller sitting right here, but right now that space will be left open. These are the cables I'll be using to connect the inverter. They are double aught or 00 gauge cables. Originally I was going to get 4 aught, but these were cheaper, so I got these instead. Next, we will install an A&L fuse, 150 amps. This is a basic fuse block, and it has a replaceable fuse, which is very good for high amperage things like inverters. I kind of prefer fuses in this case versus a circuit breaker. Later on, I may upgrade this to something else, but thankfully fuses are quite affordable. At a later time, I may actually replace this fuse with a higher quality version. But for now, to get up and running, this fuse will be just fine. I'm going to use my little Floron portable power system to run my camera light here. And you just turn it on. I should be able to run this camera light for at least, I don't know, maybe an hour. There we go. One of my favorite devices in the shop. Alright, we got the lighting back up, and what I need to do now is put some temporary cables on these batteries, because I do not have the ones that are 8 inches that go from here to here. I have some 6-inch cables, and they're just about a ½ inch short of where they need to be, unfortunately. So I'm going to use some longer cables temporarily just to get the job done and get my air conditioner up and running, which is most important. I hope you guys can see what I'm doing here. I'm taking the battery handles off for now, because these batteries are going to be mounted right here on the battery shelf. I'm using a bus bar for the time being to mount the fuse and the other things that are going to be on here. I will probably be redoing this at a later time. I have some other items coming that are going to be attached. Those will be installed later. Right now I just want to get my air conditioner running as quickly as possible. So I need to install a fuse. Let me go ahead and do that. The fuse is going to be an A&L fuse. It will do for now. And I think I'm just going to mount it right here for now. Just see how I like this. This is temporary. Of course, I'm going to rework this later. It's hard to figure out where all the wires are going to go until you've got everything in place. I'm not too worried about exactly where everything goes. I'm just going to go ahead and hook it up. We need to add the parallel cables, which is going to be right here. And I'm going to try to do them as neatly as I can until I get the short cables that are going to be thicker. They're going to be a lot better for this. But the long cables will do the job. I seriously doubt the air conditioner will notice the difference. Go ahead and attach the positive side. I'm working on the positive side at this point, doing all the positive hookups. And I will probably move that fuse at a later time. Now for the positive side, I've got this double alt cable. It's really thick, but it's actually a little too long. I may actually want to try a shorter cable in the future. However, like I said, I just want to get my air conditioner running, so rather than be too picky about how long everything is, let's just go ahead and hook everything up and see how it runs for a while. And over time, I find that as a man, I have to spend a lot of time thinking things through. And sometimes it's better just to go ahead and work with what you have, get it running, try it out, and then you can always make tweaks and adjustments later. So I'm not going to worry about exactly where all the cables run and all that stuff. Alright, double alt cable goes on the top of the fuse with a washer, lock washer, and a bolt or a nut. Let's try this out. Let's see how this cable bends or flexes. I don't know. It's a thick cable. However, the quality is very high. Just so you know, I get my cables from Gauge Wire and Cable on eBay. I'm not paid to say that. He makes the best cables I've ever seen, and for the best price I've ever seen. And I bought the cables there for years. Alright, there's the positive through a fuse. Of course, it isn't a good idea to have wires crossing over each other, especially if they're positive and negative, but bear in mind that this is going to be a smoke test. This is going to be an initial setup. These are not the right cables, and this is not the final configuration, but it's pretty close. I'm going to now do the negative side, and I'm going to use the same type of cable to do the negative parallel. In the future, I'm going to install a Coulomb counting amp meter, and there will be a shunt somewhere in this area and a little computer screen to show me how much power is in the batteries. I also expect several more batteries to be coming as soon as possible, but believe me, these will run an air conditioner very easily, especially when you have 1200 watts of solar backing them up. And I don't particularly like having all these long cables, but they will do the job for now. I'll just go ahead and slap them on there, making sure not to touch the other end to the positive side because that would be a problem. And I think I'm just gonna, we'll just do it like this. Not pretty, but there are worse things, believe me. Alright, there's our negative. The batteries are now in parallel. And now all I need is my big, thick negative cable. Got that right here. And this is a double alt cable. And we can go ahead and have this come over from this battery terminal over to the negative side of the inverter. How exactly am I going to mount that? That's the question. As it turned out, I don't really care for having the negative cable too close. It's probably going to be better to have the positive attached over here. And you're supposed to go opposite corners. I've found that getting cables routed can be very tedious, and it's better just to go ahead and hook them up and see how you like it. And you can always make changes later. I've swapped the way the negative cable comes. It's flipped over, and it's a little bit better. I do like that. It's going to be an evolving situation. I think I will wait till I get the battery parallel connections before I start worrying too much about it, but I like this a little bit better. I kind of like the cables to look a certain way. And of course, I'm going to relocate this fuse so that I'm pulling from the opposite corner of the battery bank, because I got my negative here, and I want to pull not from here on the positive, but from here. However, it's not the end of the world. I'll just swap that around. Okay, that's the current state of affairs. I managed to set the cables up where they're not crossing positive and negative. That will be enough to get my air conditioner up and running, and I'll deal with the cable mess later. Cables are always something that require a lot of thought and planning, and I didn't have a lot of time to plan this, so. The charge controller must have its own circuit breaker on the output. For that I will be using a resettable thermal circuit breaker. This is not a cheap circuit breaker from an unknown brand. It is a Cooper Busman 150 amp circuit breaker, resettable, and it's a good quality part that's going to last hopefully a long time. Cheap circuit breakers that you commonly see in DIY installations are not trustworthy, they do not have accurate trip ratings, and sometimes they just plain fail. It's not worth risking your entire setup on a circuit breaker that just looks like one. It seems difficult to find proper brand name circuit breakers anymore, especially if you're on a budget. This breaker was not too expensive, and I believe it was new old stock, so I think I got a good deal. I highly recommend against the cheap ones you find. I've tested a lot of those. They failed. They didn't work. They didn't perform as advertised. Whereas this is an actual brand name breaker. So I'm going to go ahead and temporarily attach this using an extra short cable just to get myself up and running. And then eventually, once I decide exactly where my cable layout will be, probably it will end up right over here or right over here. I'm not really sure, and until I make up my mind, I don't want to start drilling holes in the board. However, it's getting really hot and I need that air conditioner running, so I'm going to go ahead and just use a short cable to put this in circuit. You will notice this circuit breaker has the word BAT on it. There it is. You can see right there the word BAT. That's battery. AUX, aux, auxiliary. So BAT means that goes towards the battery. You can see already this circuit breaker is no joke. It's actually telling you which end connects to the battery. It's important to pay attention to these details because you can hardly see that. You have to look pretty close to see it. So right here is going to go with a short cable to my battery, and the other end will go to my charge controller. How many times will I utter the word temporary? But that's reality. There's only one of me, and I've decided the most important thing is to use whatever time I have to go ahead, mount this equipment on the wall, and start using it, and then I will refine the layout later. Alright, there's my short jumper cable. This will attach to the battery and protect my charge controller. In the future, as I refine the layout and the wiring and everything, I will certainly post more videos and show that work. Right now, I'm just trying to get up and running, so I just want to make sure and make that clear. This is not a very perfect setup. I like to do a neat job with cables and wires, but sometimes you just need to go ahead and get it working. And I need to buy specific cables just for the charge controller, and I can't really buy those cables until everything is mounted on the board. Once everything is mounted on the board, I can start measuring for cables and get the exact length that I want. Did I mention the word temporary? Just wanted to make sure and point that out again, as if I haven't already. I've gotten some blocks of wood here, and I'm going to use that to support this circuit breaker temporarily until I decide exactly where to mount it, and or I may even choose a different circuit breaker, who knows. I'll go ahead and just put everything together the way it is. Hopefully you can see what I'm doing. I had to switch off of the GoPro for now. This GoPro is very difficult to use, and I have to limit how much I use it. It's going to waste a lot of time if I don't. I'll never get anything done, but I'll hopefully get better at using it. Yeah, let's just try the circuit breaker out. It's better than nothing. And of course I've got the good old-fashioned MC4s, and I'm going to feed MC4 cables right over from my other solar panels into here just to get it up and running. We'll see what happens. And the other thing I did, I forgot to mention, I didn't show it on camera, but I got a new 12-gauge extension cord, and I ran that all the way up into the attic, through the foam board, behind the power board, up overhead, and then it comes down and it goes into the other room where the air conditioner is. So this is going to plug into the inverter for now. Later I'm going to have some power sockets over here, but that's going to be plugging right up underneath the inverter. You can't see the outlet, but it's right up underneath here. Well, there it is. I intend to buy some better cables that will fit here better. However, I'm not going to buy them until I get the rest of the batteries. There's going to be more of them here. And once I have everything pretty well the way I want it, then I will start buying more cables. Cables are not the cheapest thing, so I don't want to go out and buy a bunch of cables and find they don't fit. What I have to do now is tighten up the cables to the inverter. I've got an A&L fuse here, 150 amps. Charge controllers coming off that into a circuit breaker. And cables go down into the charge controller. Temporarily connect the PV cables to the MC4 connectors. I will need to switch on the inverter. And we've got a plug here that's going up into the attic or over the shop. This is going to provide AC power to the air conditioner and anything else I want to run. Eventually though, I'm going to need a bunch of power outlets here so I can power my computer and everything else. And there's a hardwire capability here that I need to use. All that'll be done in good time as soon as I can. Oh, and just for safety, because I am error prone, I'm putting these little plastic caps on the battery posts. Just a little bit of extra safety, and it looks kind of neat. I have a lot of them, why not use them? And I cannot currently use my A&L fuse cover, so hopefully that won't blow. And hopefully I don't touch a wrench or something. By the way, you should wrap your handles in tape. I didn't do that, but you should wrap the metal handle in tape, because if you drop this across those terminals and you have, let's say, 10 batteries in parallel, the BMS isn't going to protect you. It's going to make a big show. Alright, I have some cables here. These are temporary. These are really high quality. These are my favorite MC4 cables. They're made out of high strand count silicone. And outside my workshop I have a 1200 watt solar panel array that I'm going to plug into this charge controller. Eventually I'm going to need to install a breaker. I don't have the breaker installed. So in the interim, I'm just going to run this cable. This is going to allow me to get the batteries charged. The other day I tested these WattCycle batteries in a review I was doing, and they're basically flat empty. Okay, they're not 0 volts, but they're empty. So that means I need to go ahead and get some charge in them. Alright, this is positive. Now I need to verify the polarity of this charge controller before I hook these cables up, because MC4s are tricky. They can be the wrong way around. I got to make sure of that before I hook them up. Alright, the polarity has been verified. These cables are not live. It's okay to go ahead and plug them in. MC4s, you really shouldn't plug them in when they're live. And yes, the red and black is backwards. You got to know what you're doing. But I did verify the polarity. And let's get the heat shrink in place. Alright, so the charge controller, the inverter, and the PV is all wired in. Now I need to turn on the inverter first. Let's go ahead and do that. Alright. Yep, 12.7 volts at rest. Now let's turn on the charge controller. Alright, charge controller is on. Let's check the settings. I did actually turn my voltage down a little bit because of some testing I was doing earlier. These batteries, as I said, were deep discharged, so I don't want to pile a bunch of current into them. Alright, now let's throw the breaker for the solar panels. 70 volts. There we go. Not getting much power, so let's change the voltage rating here. DO2. Kind of doing these by memory. See if that helps. Alright, we're up with 21 amps, and I'm going to let this run for a while before I let the current really dump. 17 amps. As I said, these batteries were deeply discharged, and I'm not going to dump the current in them just yet. I'm just waiting for them to get some power in them, and then I'm going to let this thing fly. In the meantime, let's go check the other end of this cable to make sure we're getting power. And to do that, I'm going to use a... let's see if I can find it. Yeah, one of these test meters here. I'm going to use one of these test meters to see if I'm getting power. Really could use some light out here, and an air conditioner would be nice. Yep, 120 volts, so guess we're ready to run stuff now. 380 watts, 67 volts, plenty of more room to go. I think it's time to start the air conditioner. I think I'll let the voltage come up to around 13 volts for a while, and then I will turn that air conditioner on and let it run. Okay, the batteries have been getting some charge for about an hour now. I've got a makeshift voltmeter up here just clamped on here so I can see what the batteries are doing. And I installed this AC watt meter. This is a power strip I bought recently, and that's eventually going to be probably hardwired into the terminals which are hidden behind here. For the time being, however, I've plugged it in directly to the outlet on the inverter. It only has one outlet. Got my camera lighting here, and this goes over to the other side of the workshop where the air conditioner is. Let's go to voltage, 121.2 volts, but of course there's going to be some voltage drop. It's a 50-foot cord. But let's go ahead and see if the air conditioner will kick on. Air conditioner is over here, and the extension cord that I ran the other day goes up in the ceiling, and it crosses over and it drops down here. And there it is on the other end. That's the business end. This is where all the air conditioner and the lighting and my shop filter and everything else is going to be plugged in. Ironically, I need to use the air conditioner to do an endurance test on this solar generator here that I'm reviewing. I am doing a long-term endurance test on that machine. That's the Vitomin Jump 1800. And of course I use the air conditioner as one of the primary loads to test the inverter and stress the system to see if there's any problems. However, right now I want to go ahead and turn the system up, start exercising my inverter and batteries, and see what happens. So here's the plug that goes to the air conditioner. Let's see if I can get that plugged in with one hand. On second thought, I need some light first, so I'm going to plug in my LED floodlight, which is on a different cord. Okay, that's plugged in so I can see what I'm doing. Now for the air conditioner. Alright, I got the air conditioner plugged in. Now it's time to see if I can run it. Time to make history. First test of the off-grid air conditioning system. Just heard the compressor kick in. Yeah, I can hear it running. Alright, there's the off-grid air conditioning. Let's go look at the other end, see what's happening. Pushing 800 watts per second there. 500 watts. $540. Yeah, it's jumping all around there. And the inverter, 30% load, 12.9 volts, 120 volts. There's what the air conditioner is using, 440 watts. Very good. Excellent. Seems to be working. Of course, the fan came on and it's really quite loud, but at least I know it's doing the job and cooling it. 40 amps. That's about right. Let's see what the temperature is. 42 Celsius, which is not bad, by the way. That's pretty good. About 40 amps there, 550 watts. Impressive. Well, we'll see how this Make Sky Blue does, and this amp NVT low frequency sine inverter. I'm hoping this equipment will be very reliable, of course, but just have to test it and see what happens. Right now I'm waiting on some additional batteries. They will go right here. I believe I will have room for at least 2 or 3 or 4 more if I'm creative in how I position this stuff. And eventually I may move my batteries down here. It depends. There we go, 800 watts. The sun is going in and out like crazy. It's pretty good though. 600 to 800 watts. I changed these. I made some adjustments to the voltage and now it's back up to around 700 watts if the sun stays out. And my air conditioner is using about 500, so that should slowly charge my batteries over time. As I mentioned earlier, these batteries are pretty much flat, so I need to hurry up and get some power in them as soon as I can. There's a look at the power output, about 50 amps. It's jumping around quite a lot. I would prefer it didn't jump around, but I'm not going to complain too much. I'm going to give this charge controller a chance. We'll see how it performs. Yeah, there's some voltage drop. I'll definitely need to upgrade these cables. Got some better cables in planning. probably pretty thick, and I might make them a bit shorter as well. 48 amps, 49 amps, really jumps around. Anyway, it seems to be working well, so I'm going to try and prove this system for a while, make sure everything's working well before I try to make any further changes to it. And I'll be sure to post further updates as I finish building the system. Plenty of system upgrades and videos are on the way. I'm still working on completing this installation, and all future videos will be in a single playlist linked down below. Thanks for watching, and hope to see you next time.